Okay, so today we are starting to graph trig. So 12.7, day 1, graphing trig functions. Now, graphing trig functions is actually fairly easy, especially we're going to be starting off today with just sine and cosine. Now, in order to graph trig functions, one of the things you need to know is you need to know what an amplitude is. An amplitude is half the distance between the maximum and minimum of an oscillating graph. Now, oscillating literally just means that it's bouncing back and forth between two numbers. Now, because of how these graphs are, you're also going to hear me refer to the amplitude as the distance between the midline and the max or the min. It's easier to think about it that way, actually. So, graphing these trig functions is fairly straightforward just because of the fact that they really all look nearly identical. So we're going to start off with sine and cosine, but we're going to start off with the most basic sine and cosine graphs, and then we're going to adjust them from there. So we're first going to graph the sine function. Now both sine and cosine graphs are called sine curves. Why are they both sine? I have no earthly idea, but they are. Now, when it comes to graphing these functions, we need to know a few things about them. We need to know about the period of the graph. We need to know about the amplitude of the graph. We need to know about the graph's midline. And we're also going to talk about their domain and range. Now, I'm going to tell you right now, on the homework, it's not going to ask for domain and range, but I expect that you add it. So, first off, the period. Let me pull up my unit circle real quick. So when I look at a sine function, which is the y value, remember that a period is how long it takes for the graph to start repeating itself. Well, if I look at my unit circle, and I don't actually want to write anything on my unit circle, but since this is easy to erase, I probably will. The sine function starts at 0. Sorry, I'm trying to find a bright color that isn't one I already used. So sine starts at 0, and then it starts to increase to 1/2, to square root of 2 over 2, to square root of 3 over 2, eventually getting to 1. And then it starts to decrease again, going down to square root of 3 over 2, down to square root of 2 over 2, down to 1/2, back down to 0. And then it continues to go down to get into the negatives. So as I look at my unit circle going through the y values, sine has not started to repeat itself until I get back to the beginning, until I've traveled a full circle, in other words. Now, what does that mean? That means that the period of my sine function is a full circle, also known as either 360 degrees or 2 pi radians. Now, we're going to graph in degrees probably more often than not. We will have to graph sometimes using radians, But that's only when we're forced to use radians, which actually isn't going to happen until 12.8. So you'll see me talk a little bit about radians, and in fact, I'm going to graph cosine in radians today, but degrees is going to be more common. Now, the amplitude is half the distance between the maximum and the minimum, or the distance between the midline and the maximum. So going back to my unit circle for a bit, if I look at sine, sine has a maximum of 1. And that's not just because of the unit circle. That is as big as sine gets. And it goes down as low as -1. The distance between 1 and -1 is 2. And half that distance is 1. A typical sine function, or cosine function for that matter, will have an amplitude of 1. Now the midline, we're going to talk about midline a lot more as we move into 12.8. The midline is just kind of where the graph bounces back and forth around, and it goes all the way up to 1, down to -1, up to 1, down to -1, and the middle of that is 0, specifically y equals 0. So the way we graph these functions, now I always want to graph them in a way where I can see 2 full cycles of the graph. So what I do, and it's going to be one of those ones that has a long x-axis, I put my y-axis smack dab in the middle, and I'm going to graph one cycle that goes to the right of the y-axis, one that goes to the left. So now, when it comes to our sine function, it hits all of these different values. It hits 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1, the negative versions of all of those. But it's easiest to essentially notice what it hits after every quarter of a period, or a quarter of a circle in this case. So what I do is on my y-axis, on my x-axis, I go all the way over to the right and I put a full period here. I put a full period on the left side, so -360 goes here, and I break it each half into 4 equal parts. Now, you don't have to do this, but I find that it's the easiest way to approach this. Now, I have to label at least every other of those because 4 tick marks without any labels becomes a little much. If a full period's 360, that makes every other one of these 180 degrees. Now, my amplitude is 1, which means my graph is going to go no higher or no lower than 1 above or below the midline, which the midline is right here at y equals 0. So we're going to go no more than 1 above and below that. So on my y-axis, what I typically do is I typically go double my amplitude above and below the midline. And there's a reason I do double it. I don't actually need it necessarily for sine and cosine, but it's going to help us with future graphs. Now, from here, where do I go? Well, I'm going to go back to my unit circle again. Sine at 0 degrees was 0. Then it increased by 90 degrees to get to 1. After it hit that, it went back down to 0 at 180 degrees, decreasing to -1 just to go right back to 0. So that's how I'm going to approach this graph. Sine will always start at the midline is technically what's happening right here at 0, because when theta is 0, when my angle's 0, sine is 0. Then we said it increased to 1 after 90 degrees, decreased back to 0 at 180, decreased further to -1 at 270, and then back to 0 at 360. Now, this is a periodic function, meaning what it looks like in a full period, which this is a full period, this is one cycle, is going to be the exact same thing it looks like on the other one, or on any other cycle. So I just continue to do what my graph was doing. If I look at my graph, which by the way, this is not a spiky graph, it's kind of more parabola-like. Do not make it spiky. I just continue where my graph was going. My graph, as I'm moving this way, was going down. It's going to hit the -1 next. And it's going to bounce back and forth from the minimum to the middle to the maximum, back to the middle. This is what a sine curve looks like. And then I indicate where it's going once it hits the edges. It's continuing to go up over here, continuing to go down over here. That's what a sine curve looks like. Now with a sine curve, the domain is the x values that go into a graph. Now in all technicality, I don't have an x-axis here. I have a theta axis. But no matter, my left and right of my graph, what would typically be x's, in this case is theta, there is no gaps in my graph. My graph just continues going. It goes all the way to the left. It goes all the way to the right. It hits everything in the middle. That means my domain is all real numbers, also known as theta, exists in the reals. If you want to write all real numbers, that's fine too. This is just the fancy version of it. You can just write all real numbers. That's perfectly fine. Do not write ARN. ARN has no meaning. All real numbers. Theta exists within the reals. The backward, this E looking thing means exists. The double bar R is the real numbers. That's what I wrote there if you missed it. Theta exists within the reals. I don't actually want that here though. Now my range is the Y values. It's the up and down of the graph. The up and down of my graph goes down as far as -1, goes as high as 1, hits everything in between, but that's it. So my range goes from -1, it's less than or equal to the Y, which is less than or equal to 1. It's always going to look like this for sine and cosine. Your minimum here, your maximum here, and it's always less than or equal to symbols. Cosine graph looks very, very similar. Because a cosine function does a lot of the same things. If I look at my unit circle, cosine starts at 1, decreases to 0, decreases further to -1, increases to 0, and continues to increase to 1. So it does a lot of the same things, it just does them at different places. So, again, when it comes to these graphs, I am always going to label 5 things. The period, the amplitude, the midline, the domain, and the range. Gonna make myself some axes. X-axis is a little obnoxiously long. Y-axis goes smack dab in the middle, or at least as best as I can. Cosine, much like sine, takes a full circle to repeat itself. I'm going to graph this one in radians, so a full period would be 2 pi. Doing it in radians or degrees doesn't make that big of a difference. I follow the same process. On my axis, on the far right side, I put a full period. On the far left side, I put a negative version of that. And I divide each half of the graph into 4 equal parts, labeling every other. So half of 2 pi is 1 pi, which is what goes in that middle one. If you want to label the other ones, you can as well. The first one right here would be pi over 2. Then you'd have the pi and the 3 pi over 2 and 2 pi. Going the negative direction, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. I just label every other. Now cosine, much like sine, has an amplitude of 1. So on my y-axis, I always go double that value above and below the midline, which the midline for what we're doing in 2.7 is always just going to be 0. Specifically, y equals 0. And yes, you need that y equals because it is a line, and lines have equations, not numbers. It's a simple equation, but it is an equation. Now, I want to graph my cosine function. To graph my function, I have to remember that I'm going to go as high and as low as an amplitude above and below the midline. So one thing you can always do is from your midline go up what the amplitude is, make a little line, go down from it what the amplitude is, make a little dotted line. It's not actually part of your graph. Technically, neither is the midline, hence it's also a dotted line, but it can help you kind of gauge that maximum and minimum to make sure you don't go above or below it. Now, sine started at 0 because sine of 0 degrees was 0, but cosine of 0 degrees is 1. So cosine starts at its maximum. So cosine starts here. Once you hit the maximum, the only location to go is downwards. And it's going to go down to 0, down to -1, up to 0, up to 1. The reason we break the period into 4 parts is those are always then going to break it up as maximums, minimums, and midline hits. If you break it up into 4 parts, you don't actually have to think about where those things are going as much. Okay, moving to the left, I was at the maximum. I have to go downwards then. After max, I hit midline, then minimum, then midline, then maximum. I always have to go all the way from max to min before I change directions. My cosine function looks like the sine function, sorry. Let me try to make this a little less bumpy. I'll start over here to make it easier. It looks like the sine function. It looks kind of like the u's. Try not to make it too spiky. It just started at a different spot. Make sure at the end points you indicate what direction it's going next, which in this case, they're both going downwards. The domain of a sine and a cosine function will actually always be all real numbers because the graphs are always going to look like this, which means they're always going to go all the way left. There's always going to go all the way right. They're always going to hit everything in between. So you're going to typically see me write theta exists within the reals. If you prefer to write the words all real numbers, that is fine. Just understand that I'm going to write this because I don't really like writing all real numbers. Range. My graph is bouncing up and down between -1 and 1. Start with the minimum, less than or equal to y, less than or equal to the maximum. Now, these are the basic functions that we work with. But when it comes to our ones that we're going to graph, they're going to be slightly different, but not a whole lot different. The only thing we're going to do with them is we're going to do transformations on them. Specifically today, we're going to see equations that look like y equals a times sine of b theta, or y equals a times cosine of b theta. Now, a and b control a couple of things on the graph. A controls the graph's amplitude. Because if I take a graph and multiply all of its numbers by a number, it's a scale factor. All of the numbers are either going to get bigger or smaller depending on what I'm multiplying by. The absolute value of A will be the amplitude. Because of the fact that the amplitude is typically 1, if I multiply all of the numbers by 5, now the highest it goes is 5, and the lowest it goes is -5. Hence, the amplitude is just the absolute value of whatever that A is. Now, A can be negative, and if A is negative, the graph will end up flipping over the x-axis or theta axis. And what that means is things that were maximums will now become minimums, and things that were minimums will now become maximums, and we'll address that as we go. Now, the B will control the period. It controls how quickly we go through the graph. Period of any of our trig functions is always going to take the typical period for that function and divide it technically by the absolute value of whatever that B is. Now, for sine and cosine, since their period is typically 360 or 2 pi, that means you're going to take 360 degrees, divide it by the absolute value of B, or if you're graphing in radians, 2 pi divided by the absolute value of B. So, let's get into ones where we're actually graphing and talk about the process. We're going to graph the following. Y equals 2 sine of 3 theta. Anytime we graph these, we got 5 things we're talking about: the period, the amplitude, the midline, the domain, and the range. I generally do the first 3 before I graph. I do the second 2 after I graph. I could do domain and range before, but there's a reason I tend to do it after. Has to do with something we're going to see in the future. So, period of a typical sine function is 360. If you want to find the period of our current sine function, you take that typical period, 360, and divide it by the absolute value of B. Now, B is the thing that comes in with theta. That's B. A is what comes out front. So 360 divided by B is 360 divided by 3, which is 120 degrees. So here's what that means for my graph. I make my big long theta axis. I make my y-axis. I find that period, and then on the far right side, I write the full period length. On the far left, I write the negative version of it. Divide each half into 4 parts. You've almost probably heard me say this twice before already. You're going to hear me say it a lot more. I'm going to label every other one of those. Half of 120 is 60, so 2 in is 60, and then negative 60 on that side. Okay, amplitude. Amplitude is given by the absolute value of the number in front of the sine or the cosine. Note, I just said sine or cosine. Tangent, secant, cosecant, and cotangent are different. But today we're just doing sine and cosine anyway. So, the absolute value of A, or the number in front, is the absolute value of 2, and the absolute value just makes a number positive, which was already positive, is 2. So, on my y-axis, I go up at least double that number above and below the midline, and for now, our midlines are always going to be at y equals 0. So I'm going to graph my midline on here as a dotted line. And then double the amplitude. The amplitude's 2. Double that is 4. 4 above 0 goes up to 4. 4 below 0 goes down to -4. And I still want to do the half of that as well. Now keep in mind that that half of that is my amplitude, above or below the midline more specifically. So my maximum and minimum are going to be 2 and -2. You don't have to draw those yellow dotted lines, but they can help. Now from here, once I have this built out, between cosine and sine, the thing I look at is, does it start typically at its maximum, at its minimum, or at its midline? And then the other thing I do is I ask, was it flipped over? Sine typically starts at the midline. The reason sine starts at the midline is sine of 0 is 0. I can always refer back to my unit circle for that. If I'm like, okay, I don't remember if it starts at the midline or if it starts at the maximum, just look here. Sine starts at 0. 0 is the middle. Cosine starts at 1. 1 is the maximum. At least of a typical graph. It changes when we change the amplitude, but it helps you with where it starts. So sine starts at the middle. Now, since there's not a negative in front, this one did not flip over, which is good to know. We'll talk about what happens when it does. Sine starts at the middle. Now, sine typically increases first. If it flipped over, it would decrease first. But it doesn't. It increases. Now, when I talk about it increasing, I mean as we move to the right. As we move to the left, it does something different. If I'm in the middle, the only place I can increase to is the maximum. So after a quarter of the period, I go to the maximum. Then, if you hit the max, you have to turn back around. Instead of going up, I'm now going downwards. I have to hit the middle at my next quarter mark before I hit the minimum at my next quarter mark. I do not change direction until I've hit the min and the max. Once I hit the minimum, I change my direction. Now I have to go upwards back to the midline. I follow my pattern working to the left. As I work left, from here to here, my graph was going downwards, which means I need to continue to go downwards because I only change directions at the minimums and the maximums. Hit the minimum, go upwards to the mid, then to the max, then back to the middle. I connect it with my more U-like graphs. Don't make it too spiky. I understand if occasionally it gets a little spiky, but if it starts looking like a zigzag, For sine and cosine, the domain is actually always going to be all real numbers. The range, since this one bounced back and forth between -2 and 2, I put the minimum first, less than or equal to y, less than or equal to the maximum. Okay, let's try another. Y equals 5 cosine 4 theta. Again, we got our 5 things always. Period. Typical period for cosine is a full circle, or 360 degrees. We're going to divide that by the 4. That's the b value. That's what we divide to get the period. 360 divided by 4 is 90. Far right goes 90, far left goes negative 90. Divide into 4 parts. Half of 90 is 45, so that's 45. And that's negative 45, and I don't want to forget my degree symbols. Amplitude. Absolute value of the number in front of the trig. Absolute value of 5 is 5. On my y-axis, I go double that above and below the midline, and the midline for now is still at y equals 0. It will be at y equals 0 until our graph starts shifting upwards or downwards, which isn't until 12.8. So I graph that line. Five doubled is 10. 10 above and below the midline. If the midline's at 0, 10 above that's 10. 10 below that is negative 10. I do this in order to get a good view of my entire graph, as well as a little bit of room above and below it, which is going to be important later. Now, for the graph itself, cosine. Cosine typically starts at its maximum. In this case, the maximum is going to be 5 because that's the amplitude, and the amplitude goes above and below that midline. You don't need these little yellow highlights, but if they help, you can do that. Now, my graph did not flip over, so I'm still going to start at the maximum. If it did flip over, maximums become minimums, and I would have started at the minimum instead. When you hit the maximum, the only place you can go is down. Do not change directions until you hit your minimum. Remember, each quarter of a period is where you're going to hit either the midline or the maximum or the minimum. I follow my pattern going left to right. It was going up here, but then it hit the maximum, so it has to go back down. Make sure when you're graphing these, this is a periodic function, which means every cycle should look the same. In other words, now I'm going to highlight part of the graph. Don't highlight like this. But if this part of the graph doesn't look like it was picked up and copy and pasted to this part of the graph, you got a problem. Up here, down, back up here, down, back up. It does. Domain and range. Domain for sine and cosine's easy. All real numbers. Range. Start at your minimum. Less than or equal to y, less than or equal to the maximum. Okay, final example. Same 5 things for now. Eventually, we're going to have more things we have to identify right away. We're not there yet. Period. I'm working with cosine here. Cosine's typical period's a full circle, which is 360. I'm dividing it by the 6. 360 divided by 6 is 60 degrees. Amplitude is the absolute value of the number in front of the trig. Absolute value of A. Absolute value of negative 4 is just positive 4. Midline for now is just y equals 0. Far right side is a full period length. Far left is a negative version of it. Divide into 4 equal parts. Now, by dividing things into equal parts is going to be a huge thing in the future. So try your best to make them equal. They don't have to be perfect, but if they're not equal, even remotely, it's going to be really hard to see what's going on with your graphs. Especially when we start doing like the cosecant and secant graphs. Okay, my amplitude is 4. Since my midline is at y equals 0, 4 doubled is 8. 8 above 0 means I need to get on my y-axis up to at least 8. And down to at least negative 8, because 8 below 0 is negative 8. Keeping in mind that my amplitude is still only 4, so 4 above 0 is 4, 4 below 0 is negative 4. Now cosine, again, typically starts at its maximum, but this one flipped. If it flips over, then what is typically a maximum flips to minimums. What's typically a minimum flips to a maximum. So while I typically would start at the maximum, since it flipped over, I'm now going to start at the minimum. From the minimum, the only place to go is upwards. So I go here, keep going up until I hit the max, back down until I hit the min again. I was at the minimum, go in this direction. I have to go upwards, back downwards then. Make sure you connect your graph. Don't be too spiky, and then give me direction of where the graph is going at its endpoints. Domain is still all real numbers. Range. Now, just because it flipped over, that doesn't change anything about your range, because your range is just the y values it goes back and forth between. In this case, negative 4 less than or equal to y, less than or equal to 4. Now, just a quick note. If you put a negative on a sine function, for example, I'm just going to draw over this graph. Don't change this graph. But if there was a negative here in front, minimums and maximums switch. Midline hits are still midline hits. My graph would have still gone here, but instead of going upwards to the max, it would have gone down to the minimum and then bounced back and forth. If this one had been flipped over, it would have looked like this. It wasn't flipped, so I'm going to get rid of that, but so I hope that makes sense. Please use one another as resources as needed. Your homework is on page 841. It is numbers 10 through 18, evens. It's not a whole lot of problems. It's a whole 5 problems for you to work on. Do make sure to add domain and range to things you're identifying. It talks about identifying the range and the amplitude. Please also identify domain and range just like we did.